Hey guys, in this video we're going to be doing the last lesson of our notes, which are real world problems. And we typically refer to those as projectile motion questions because we're projecting an object in the air. Typically all of the real world problems or the word problems you see are going to be tossing or launching an object in the air. And all of these follow the same pattern. Anytime you throw up a ball or whatever into the air, it's going to come back down because of gravity, and some science behind it gives it some kind of pattern. Every projectile motion equation has the same A value, the number in the front, and that number is -16. You can ask your science teacher, your physics teacher, why this is. I don't know. The B value is the velocity. So how fast and how hard it is thrown. And the C value is the starting point. Now, you may not have a C value if your object started at the ground. And so we would assume that it is 0. If the problem doesn't give a starting point, we assume it's 0. Some differences you'll see in these is we use a different variable. We use h of t. This is the height given the time. So instead of x, we're going to have t to represent time. So it's -16 t squared plus the velocity times t plus my starting point. So you will plug in a t, so along our x-axis, that is the time in reference to height. So I'm going to draw a little graph down here in this space that I have. So my x value is time, the number of seconds, and then height. Typically feet. So let's say that, let's say that a ball starts on the ground. So here it is, at 0 seconds, it's at 0 feet. And then at 1 second, let's say it's 1 feet. And then it keeps going up. It's going to form a parabola. So there's some typical questions that you will see, and I'm just going to give you a brief, here's what you do, here's how you answer those. So it might say, find the height at a specific time. So it might say, well, at 2 seconds, what is the height? So it's giving you the x value. It's asking for the y value. So plug that number into t. If it gives you the time, if it says this is the time, that's your t. That's your variable. You just plug it in. If it says to find the maximum height, right, that's at your vertex. Now, if it's asking for the maximum height, your height is the y value. So this is the y value of your vertex. If it says find the time that it takes, so how long does it take to get to that maximum height? How long does it take to reach the peak? This is the x value of the vertex. regardless of which two of those questions it asks, the maximum height or the time, you have to find the x value first. So if it only asks to find the maximum height, you still have to find the x value. You still have to do that. And remember, this is negative b over 2a to find the x value of the vertex. And if once you find the y value, you're plugging in the x value. Then it might say, how long does it take to reach the ground? So the ground would be when the height is 0. What special points are those 2 points? Those are your x-intercepts. For all of these questions, you're going to do it a little bit differently. For one, you have to use the quadratic formula. Because most likely these are not going to factor well. Just going to go ahead and start out using the quadratic formula. And something that's going to make your life a little bit easier is that you are just going to type the whole thing in the calculator. You don't have to do it step by step. You don't have to simplify the radicals. And here's why. When we're talking about real world scenarios, you're not going to go out and say, I threw a ball in the air and it took 5 radical 2 seconds to hit the ground. No, you're going to say it took 6.72 seconds to hit the ground. So real world scenarios, use it like you would in real life. Now, you may get a negative number. And if you get a negative, just cross that one out. What that means, let me erase here on the side. You don't have to redraw this. Let's say that when you throw an object, you're starting somewhere higher up. Maybe you're standing on a roof or something, and you throw it up in the air and then it comes back down. Well, mathematically, your calculator doesn't know that it's a ball throwing in the air and you're starting at a certain height. So it's just going to treat it like any other parabola. And these would have 2 x-intercepts, but this one would be a negative number, maybe like -1. You just ignore that one because that doesn't make sense for these scenarios. Alright, so let's look at this first example. We've got lots of questions here. A soccer ball is kicked from the ground, meaning the starting height is 0, with an initial velocity of 90 feet per second. The equation h of t equals -16t squared plus 90t gives the height of the ball after t seconds. So this one actually gave you the equation. You didn't have to put it together. Question number 1 says, what is the height of the ball at 1.2 seconds? So it's giving us a time. This is t. So we're going to plug in. So the height at 1.2 seconds equals -16 times 1.2 squared plus 90 times 1.2. And just type that in your calculator. I would recommend using the store button on these. So I'm going to type in 1.2, hit the store button, and then put x, because we use x for everything. And then I'm going to type -16x squared plus 90 times 90x. And I get 84.96. And this is feet. If you don't have the calculator app, I recommend getting it. Let's see if I can find it. Oh, here it is on the right of my screen. It's a pink app called Calculate 84, and it has a white calculator on it. And this is on my iPad, but you can also get it on your phone. I know it works with Apple. You used to get it with Android, and it does pretty much all the same things that the calculators we have in class use. All right. Number 2, how long? So it's asking for a number of seconds. It's asking for the time. How long does it take for the ball to reach its maximum height? So remember, the maximum height is the vertex, and so the time is the x value of the vertex. So we're going to do negative b over 2a. And it's actually t equals. I'm so used to putting x. So negative 90 over 2 times negative 16. So you can type that in your calculator, and you get 2.81 seconds. I'd like you to go at least to 2 decimal places. Number 3, what is the soccer ball's maximum height? So we're going to take that 2.81 and plug it back in. So h of 2.81 equals negative 16, 2.81 squared plus 90 times 2.81. If you want to be more precise, instead of using 2.81, use the entire decimal. So if you actually typed it in your calculator, it's actually 2.8125. I'm going to the store button, and it's going to take my answer from the previous line and store that as x. And then I'm going to go type in my equation. Negative 16x squared plus 90x, and we get 126.56 feet. So the ball reaches a height of 126 feet. I feel like that's a robot kicking that, because that's extremely high. If you think about a building, typically one story is about 10 feet. So that would be like a 12-story building. So this is probably some mechanical object kicking the ball. All right, number 4, how long does it take the ball to reach the ground? So we're going to do the quadratic formula. Okay. So this would be negative, 90 plus or minus the square root of 90 squared minus 4 times negative 16 times 0, my c was 0, all over 2 times negative 16. And we're going to type this whole thing into the calculator, and I'm actually going to show it to you on the calculator app so you can see it being typed in. So alpha y equals, negative, start over, negative 90, we're going to do plus first, the square root of 90 squared minus 4 times negative 16 times 0, all over 2 times negative 16. And the first one I get is 0. So remember, this ball started on the ground, so this is essentially the starting point. And then I'm going to go back up and pull down this and change that to a negative. I just hit delete. You could retype it if you wanted. And we get 5.625. And really, the one that it's wanting the answer is 5.625 seconds. It's not. We don't really care about the starting point. All right, next one. An apple is launched directly upward at 64 feet per second from a platform 80 feet high. And the first question is to write the equation to represent the height. So we always have h of t equals, it always starts out with negative 16t squared. So the feet per second, that's your velocity. So plus 64t, and then the platform is our starting height, plus 80. How long does it take for the apple to reach its maximum height? So this is asking for the number of seconds or the x value of the vertex. So we're going to use the negative b over 2a formula. Negative 64 over 2 times negative 16. And we get 2 seconds. Well, what is the maximum height? Well, I'm going to plug that back into my equation. So h of 2. Negative 16 times 2 squared plus 64 times 2 plus 80. And we get 144 feet. Number 7, what is the apple's height after 0.7 seconds? So this is asking for a specific height. So we're going to find h of 0.7 or 0.7. So I'm just plugging that in for t. Remember, you could type it out like I have it written, or you could use the store button. I prefer using the store button. I think it's faster. So when we type that in, you should get 116.96 feet. All right, number 8. How long does it take the apple to reach the ground? So where is the height 0? Those are your x-intercepts. So the quadratic formula. I'm just going to rewrite this here for you. So negative 64 plus or minus the square root of 64 squared, minus 4 times negative 16 times 80, all over 2 times negative 16. negative 64 plus the square root 64 squared minus 4 times negative 16 times 80, oops, all over 2 times negative 16. We get negative 1. And then I'm going to, arrow up until that's highlighted in pink and hit enter. And I'm going to scroll over. Till I'm right there in front of it, hit delete and change it to minus, and we get 5. So the one that actually counts for these problems is the 5 seconds. Now this last example, I would like you to pause the video and try it yourself. You probably will want to refer back in your notes, but just see if you can figure these out. An arrow is fired off a 360-foot cliff at a speed of 95 feet per second. Number 9 says to write the equation. So h of t equals negative 16 t squared. They all start out like that, every one of them. Plus 95t plus 360. Your 95 is the feet per second. That's your velocity. And the cliff, that's your starting height. How long does it take to reach the maximum height? You should have done the negative b over 2a. So negative 95 over 2 times negative 16. And when we round it to 2 decimal places, that's about 2.97 seconds. And then when we plug that in, just going to plug it in for t. We get 501.02 feet. Number 11, what is the height after 1.6 seconds? So we're going to find h of 1.6. The good thing about using the store button is that I've already typed in the equation. So once I hit store, I can scroll back up until I've highlighted over that equation and hit enter, and it brings it back down. I don't have to retype it all in. 471.04 feet. How long does it take to reach the ground? So again, this is quadratic formula. Negative 95 plus or minus the square root of 95 squared minus 4 times my negative 16 times 360. And all of that is over 2 times negative 16. Typing it in right now. So the first time you do it, you get negative 5.1. That rounds up to 5.1. with the minus, you get 6.096 or 6.1. And the one that we use is the one that's positive, 6.096. If you have any questions, don't hesitate to email me or reach out and ask. Hope everyone has a great day.